Yes, Gopi.
Yes. So good evening, one and all. I welcome all of you to this great seminar on machine learning and deep learning, organized by World Resource Webinar Resource Dr. Umachandran is coordinator for this. I really appreciate his effort. I welcome the resource person, Professor Ravinder, Rena, NWU Business School, Northwest University, South Africa, and Dr. Krishnan Umachandran, Nelcast India Limited, and Rajani, Thakur, Technical Consultant, New Delhi, and Dr. Varalatchoumy, Department of Computer Science, Cambridge Institute of Technology, Bangalore. Really welcome all of you for this the hot topic of machine learning and deep learning webinar. I request Dr. Umachandran to deliver.
Professor Ravinder Rena has joined. Let him start.
Okay. I request Ravinder Rena to give a welcome address. Welcome, sir. Really welcome to this program. Yes, now is connecting audio.
Yeah.
Yes.
Hi, colleagues. Can you hear me?
Yes.
Yeah.
Yes,
sir. Yes, sir. Yes, sir.
Good
evening, sir. Good evening. I am Professor Gopinath from Venkateswara College of Engineering. Yes, sir. Nice to seeing you on the screen. Welcome you, sir, for this session. I request you to give a welcome address, sir, to this webinar.
Thank you, sir. It's a great honor for me, ladies and gentlemen, that I'm part of your international webinar organized by World Global Resource World Resource Webinar. And particularly, I must be thankful to Dr. Umachandran, who is the organizer of this event. And there are also fellow colleagues who are part and parcel from South Africa, from different other countries in the world. Ladies and gentlemen, the topic that was chosen for this particular day is that machine learning and deep learning, which is very, very pertinent to all of us, whether we are technocrats or whether we are general practitioners, whether we are economists, or maybe we are managers in general. So the deep learning and machine learning is very pertinent area that one can look at and explore. Let me give you a brief note in the interest of time that if you look at for the past 200 years, how the gradual evolution of the technology has been changed. We got the first industrial revolution, which was taking place around 1760 to 1840, about 80 years period, particularly taken place in UK, and gradually it was spread to European countries and maybe parts of the world. And that is also the first industrial revolution became a sin to the developing countries because of the fact the industrial revolution alone created this mess that we're experiencing today with the divide in South countries. So that is the first industrial revolution. I don't need to go to the details of it because of time, and maybe probably the steam engines were invented and so on. Then we got the second industrial revolution, which is electrification. How that was taken place about little more than 120 years. And city like Bangalore, it has got first electrification. The streets of Bangalore was been illuminated only in 1905. That was probably about 117 years ago. Bangalore doesn't have electricity at all. So this is the kind of changes that have occurred. That was not long time back. It's more than 115 years ago. So that is second industrial revolution for us. Now we have the third industrial revolution, that is ICT revolution. And that is basically information communication technologies that started sometime in our 70s and 80s. And now we've been experiencing the boom of that and the fruits that of the industrial revolution, third industrial revolution brought for us. Then we are experiencing different technological advancements all over the world. I could sit in South Africa and I could able to see you and talk to you. That is the probably technological revolution. Now, if we look at the current fourth industrial revolution, which we are talking about for the past more than a decade or so, and eventually we talk about machine learning, we talk about artificial intelligence, we talk about deep learning, we talk about virtual realities, we talk about big data, we talk about Internet of Things, we talk about so many other things that are connected, maybe cloud technologies. So this is what we are experiencing. But the point of the matter here that, ladies and gentlemen, we are trying to divide further this whole world into small sections. If you look at the whole world, we have two categories. One is developed countries and second, developing countries. Developed countries are only 25% in this world. Developing countries, they are 75%. Developed countries, only 25%. Now, within the developed countries also, how many countries they are ready for this fourth industrial revolution or 5G technologies? If you realistically look at, ladies and gentlemen, we have countries like Japan, maybe South Korea and Germany. India, though it is technologically advanced country, and the CEO of Google, Sundar Pichai, come from India, but still India is not ready for the 5G technologies and the fourth industrial revolution as such, though our technocrats, hundreds and thousands of technocrats working for Silicon Valley, working for all over the world, but still India as a country is not ready yet with these technologies. So America on the other side, maybe Singapore and few other countries in Europe, they are the only one. We can even count 10 to 12 countries, they are ready for this big changes or technological changes that augmented realities and maybe big data, machine learning, artificial intelligence. So therefore, this digital divide is going to divide us further and is going to create economic inequalities so further that there are countries in Africa, for example, the continent where now, for instance, take Burundi. Burundi per capita income is less than $400, whereas Kuwait and Qatar, these per capita income more than $100,000. What is the dichotomy actually? What is the fairness? What is the equality that we could able to? Although Indians, they believe that Vasudhaiva Kutumbam, the whole world is one family, and we're really seeing that one family concept we need to question here. So in the interest of time, I don't know, Rupeji, should I have a little more, couple of minutes to conclude? I don't have the time. The chairperson gives us. We are going to have so much inequalities among ourselves. The technological world, although we look at the literacy, there are so many African countries. In this 21st century, there are more than 50 to 60% of the people are illiterates. Illiterates, just we're looking at the definition of literacy, writing and reading. We are not talking about the digital technologies. We're not talking about the 4G technologies or fourth industrial revolution, ladies and gentlemen. Even if you take that fourth industrial revolution or digital literacy or digital technological literacy, then India itself would be the largest contributor with large number of illiterates in the whole world, ladies and gentlemen, because of the fact that India alone is about 350 million people in our country out of close to 1.4 billion people, they're illiterates, ladies and gentlemen. So we need to think about that. I just would like to share some of these important aspects with colleagues here who are thinkers, who are also philosophers, who are planners, and who are, probably specialists and experts in their own field. So I just would like to pose this question. Maybe I can share some of my deeper insights in the near future when we have a detailed discussion on this particular issue. So with this few probably insights, and we are living in a complex world, living in a kind of VUCA world where there is a volatility, uncertainty, complexity, and ambiguity. So in this VUCA world, it's not easy to change so easily in the pandemic time where we are experiencing for the past 2 years. So with this, a few remarks from my side, ladies and gentlemen, I'd like to thank Dr. Umachandran, also the other fellow members who give me the opportunity to share. And I hope this particular event is going to be a grand success. I can see there are so many experts that are coming from different parts of the world. My colleague, Dr. Chukwuere, Joshi also there, and there are other colleagues. So we hope we're going to listen to those speeches and we learn from them. Thank you very much.
Thank you.
Thank you, Ravinder, Rena. Really, you have given a very good highlights that the present scenario of the world and the Indian contributions required in the Indian level of industry as well as an education side. Really helpful to the participants and other members. Thank you very much for your valuable welcome address, sir. Thank you. Thanks a lot. So,
Thank you very much.
yes, sir. Now I request Dr. Umachandran, Krishnan Umachandran, to give a talk on Industry 4.0, machine learning and deep learning. Dr. Umachandran is working for Nelcast India Limited. So welcome, sir.
Thank you. Okay. Can you people see my screen?
Yes.
Yes.
Yeah, very good. Nice of you. Friends, this webinar is morely focused towards an audience from Africa. I've been in Africa. I lived in Africa. I had been a professor in Makerere University in Uganda in the faculty of ICT. That was too far, but between 2005 to 2007, the whole 2 years I've been there. I've lived, I've breathed Africa. I've lived and I know what Africa is. So my customization of today's presentation is completely towards the African participants. Africa is a gold. I talk from my heart. It's a gold. People there already have good learning skills. They know language called English. Anywhere across Africa you go, people can understand English and they can easily put things into place. They have that ability and the propensity towards creating new things. They have the drive. So my presentation of 15-20 minutes, what I'm going to take to you is on the machine learning and deep learning. I'm going to show you a bigger picture. That is, see, if you want to learn this machine learning or deep learning, how do you do it? And why should you do it? And if at all I do it, what will I get out of it? Is the 3 parts which I'm going to cover through this evening talk of mine. So it's going to be a useful part for you because the whole world has gone into this Industry 4.0, the fourth revolution, which Professor Rena had been doing during his introduction. So this picture of a big picture, which I'm going to share, is going to go from the bracts. It is going to go in from the basics so you can understand. As you understand the bigger picture, then it will be easy for you to really push through and then take for yourself what really it matters when it comes to you for your performance. See, you could now see a model which I'm showing like a butterfly. It has 2 wings or flaps. One starts with ML and another flap starts with CS. ML is where it is connected with the machine and CS is where it is connected with a human being. See, ML, machine learning, if you see, it means it requires a machine. So the existing machines, whatever has been created up to now from the first generation or first industrial revolution, second, third, still exist. You have that machine. And this machine is going to be different in this Industry 4.0. That's what we have to understand. So all your machines will be there. All your processes will go on. But how is it going to be different in this industrial scenario? The fourth industrial scenario. So these machines are going to have something like, it is going to be linked with human beings. The part after CS, you could see the word called S/R or S-R. It's nothing but stimuli response. Human beings work or, they respond to a stimuli. And their response is based on the stimuli. That is where human beings accept or deny certain things. But when it comes to machine, there's nothing like that. Machine, when you put it on, it will get on and it will do its process. And when you put it off, it will switch off. So machine does not have a combination of our requests like stimuli or response. Human beings differ by people to people, position to position, place to place, situation to situation. We differ. But a machine is not such intelligent. So we want to bring in a machine which can be intelligent to our needs. That is where the machine learning comes. So when you want to make a machine learning, that has to come. It means that it has to go through some process, no? It has to learn. It has to, if it has to learn, then you need to create what it has to learn. Machines have data. That's called the big data. When you start it on, switch it off, and when it functions, there are a lot of adjustments the machine has to do. There's a lot of variations it has to handle. There'll be suddenly a power cut and you'll have a lot of things which is cramming the machine not to function. And some material variations will be there into a machine. So like that, you will have a lot of data that is called the big data. So this data has to be fed into the machine so that the machine can understand at various variations of these machine parameters, the machine has to function in this way. This is what is the basic input for a machine learning. Similarly, when I come to human beings, you see, when we respond to certain stimuli, we also build in a certain kind of an intelligence. Like intelligence is nothing but sometimes we do it right, sometimes we do it wrong. And at sometimes we change ourselves, remove the errors, and we change ourselves. And at times we also scale up and perform. And, when there is a requirement, we do it extraordinary. Similar things are required in a machine learning. So a machine has to also do, because the human being is putting on a lot of demands on the machine so that the machine becomes when it becomes intelligent, it should be in such a way it copes up with the demand of a human being. So now comes the part when the data is there. The data in a machine by itself is not sufficient enough to feed it onto a machine, because it has to be given in such a way that the machine can understand. That's called the information. You make the data be compatible enough to be understood. That's called the information creation. Information creation can come only when you have an algorithm. Algorithm is a kind of a code or a model or a program, what you do so that the algorithm picks these data and then feeds this into a machine, and the machine learns, okay, I have to perform when I get into such kind of a nitty-gritty or requirements, and then the machine becomes intelligent. This is where the basic requirement of machine learning comes. When a machine picks up this kind of a learning, this is called artificial intelligence has been plugged into a machine. See, getting onto an artificial intelligence onto a machine is something what a man has programmed. So the errors what we have programmed into it, the machine cannot be blamed. So the machine has to go through a lot of iterations of experiential changes that the machine has to learn and go. So the machine is a continuous learner. And if you want to create this kind of a thing, then means the human being should be open enough to tell the machine that these are the things which I require. So when you make a machine learn, you program it and do it, but certain things are kept ulterior in a human being. Ulterior because I speak something or say something, but I don't follow something, or I don't have it, I don't really mean it. If such kind of a data is being fed into a machine is going to be completely wrong. So this is the part where deep learning comes. Deep learning is the sensory inputs of a human being. See, I see something, I smile at something, I'm okay with certain facial expressions, and at certain times I don't tell, I don't reveal. All these things a machine has to understand. This is called the deep learning part. If this happens, then the cognition, correction, and amplification comes. See, I cannot be subjective. I need to be objective. That's where the machine can function. Because if a machine can do variable disposition of delivery, then that's not a machine. A machine should be true to its requirement. That's where the cognition correction has to be done. So all these parameters are to be fed into a machine through sensors or smart tools. This is where the complete amalgamation or requirement of a machine learning or a deep learning comes through. So the next part of this deep learning or machine learning is, you need to know how an example to understand, because we have people from different faculties or facilities who are listening to it. To make them understand, let me tell you, you have cars being sold year on year. Every year a new car comes in, new variant comes in, new technology comes in a car, and the car being pushed. That's the USP for selling a car. But what goes in a car is not the car, it's functionalities. That is, within the car, you have a driving system, you have a braking system, you have a power system, you have a transmission system, you have a clutch system, you have a fuel system. Like that, you have a lot of functionalities That is the one which is being changed year on year so that the car takes on for a newer technology. And then it comes out. But when you take each of these functionalities, what happens is they also have a difference. Like, for example, you take an engine. Engines are of different types. It can be a V engine, it can be an inline engine, it can be a rotary engine. It can be any kind of an engine, but all these engines have certain kind of a basic things, but it varies only with these features, which is called as components. Like a rotary engine will have a different kind of a component, like a cylinder, a different kind of a piston or a crankshaft or a connecting rod or anything. So like that, if you want to understand this, we need to understand that Industry 4.0 also has a technology. It has a lot of functionalities. It has a lot of features. It has a lot of components. Why I'm breaking through this, drilling down is, you need not get into everything. But if you can think about which is going to be really interesting to you, you can pick up that and functional. Before I go into this Industry 4.0 skills, which is going to offer a lot of employmental change or employability change in the future, you need to be very aware of what is going on in the industry so that you can pick up that particular skill and run through your career. See, Industry 4.0 fourth revolution is one which has a physical machine. It has a machine, but that machine is going to be connected with an internet. That's the more important part of it. The cloud path is going to be an internet. This internet is connecting the physical machine with a sensors which is being connected all around. Sensors here in Industry 4.0 is called IoT. I'll tell you why it is called an IoT. Because when you have a sensor is going to measure only a physical deviation or a physical change. But a physical change cannot go into a computer directly. So a sensor's input has to go into a transducer where the physical change is going to be converted into an electrical change. And then the electrical change has to be converted into a binary. And then the binary has to be fed into a computer. And then the binary data is the one which is going to go through internet to control the machine. This is where the change comes. This change is what is not like, whatever we think we can do it. There are certain things what a machine can do because it has certain kind of a limitation. And there are certain things are wish lists, human wish lists. So the difference in this auto response reaction is where the real discrimination between a machine and a human being comes. What a machine can do is user defined. That is the limitation, because you cannot make one machine and you can't ask everything can be done because it has certain kind of a design difficulty. But when it comes to a kind of a deep learning aspect, it is user dependent. If I'm going to do it, then how can I change this machine to help me out have this kind of a benefit? This is called user dependent. So you need to have user defined and user dependent components connected to an IoT so that the machine becomes intelligent. That's called the artificial intelligence. So if you want to have this kind of a machine, then means you need to get into the brick and mortar of building up a machine and how this machine can really get into fine-tuning its delivery towards your requirement. So this Industry 4.0 has a technology, it has a functionality, it has a feature and a component. Like to understand the technology, I'll give you a small acronym, which is called 2S, 2C, 2A, IBR. 2 S's, simulations and systems integration. These are 2 technologies. Then cloud computing and cybersecurity, 2 C's. Then 2 A's, additive manufacturing and augmented reality. Then IoT, big data and robotics, 2S, 2C, 2A, IBR. If you can understand, then you can focus, okay, I can pick this one and then I can drill down and then I can go and uplift my skill. So if you want to get again down, you need to have functionalities. See what Industry 4.0 functionality can happen. Interoperability. That's the great thing which a machine has. Interoperable means you do some kind of a manipulation on the data, the machine understands and does it. And if that happens anything towards the machine, it also reflects in your screen. So it is interoperable. So accordingly, you can make a feedback correction and know how, know what, and then make a correction. So this kind of a correction can happen in any of your technologies above. Then transparency. Whatever happens in one part is easily understood and it is felt the same. That's called the transparency part. And then real-time data acquisition and processing. It's not on the legacy data. It is on the real-time data, which is really happening. So you go on, live with a system. And then the digital automation, because everything is auto-fed into a system through a digital input. Okay, so these are the functionalities. And then coming down the features, you have CPS, cyber physical system, artificial intelligence, machine learning is also part of this feature. And then the predictive data modeling and digital tool. These are the components on which this feature is built in. And now coming on to the components of these features is you have hardwares connected here, softwares are there, peripherals are being connected here, electrical, electronics, and mechanical components and gadgets are being connected here. So you have a lot of opportunity to work, but where you are positioned depends on how much you have the skill and ability to function and push through. Okay, now to understand it better, see, age-old days when we had to do a kind of a plow, you want to mix a flour for making a bread. What do? You take the grain, you put it on the kind of a platter stone, and then you hit it so that you pulverize it. As the Stone Age left and then we went on to the Metal Age, the grinder was slightly different and it got devolved. But as we got into the industrializations, that is the mechanizations happened, then you had a mechanical grinder. And then the electrical part came, innovation came, the electrical grinder came. And then you had the semiconductors come in 1950 plus, then you had the, PLC based, support systems or PCB based support systems, which are also coming through your wet grinders or your mixer grinders. And today you're going to have an automated complete system where you put on your grains, it gets crushed, it adds with oil, it gets with more, your water, it mixes and it gives out your food directly. So if you want to have this kind of a machine and you're going to live with this kind of a machine, think how we have to be prepared enough. Again, you could have seen cycles, bicycles. Bicycles were one which we have to ride, get our skills with the balance, and we have to put our effort and energy so that we drive down on different roads. It was quite Hercules, but we started using it. And then it came, the bicycle went into motorized form, and then it went into a luxurious form of, going for racing and all those stuff. And then it became intelligent where the bicycle can park itself on its own. And today you have bicycles which can run on its own. You just need to sit on it and you have to go. You need not balance. The machine here, the bicycle, is the one which can balance itself. It can go, you just need to sit on it and you go on with your requirement. See, when you want to have such kind of a machines and things to be doing on, what happens is, wait, let me admit some people who are also waiting down. See, this machine, the need for such kind of a machine is dependent on various things because we want to have comfort and coziness of life and living. So what we want is, we want the machine to handle any process and for which it can take data, and we are open now to offer it data. We are not afraid of concealing our data. And then through our IoT, it picks up and it functions. But when you want to have this, what happens is you have to be more intelligent when handling such kind of a machine because machines are culpable to get into repairs and the maintenance has to be done. If you want to do all these things, then you have to be in a position that you are skilled enough to understand the requirement of it and do it. Here comes the big data. Everyone talks about big data because big data is nothing but the data what you know and unknown is also captured into it. It's a large chunk of data. By volume, it's a large chunk of data. What happens is it's caught in a different speed. It's not in a normal speed. Whenever anything happens anywhere connected to this is being captured. The velocity at which it's being captured is a phenomenal range. And it's from various locations and people. So it has a variety and it has a veracity because it has gone with a situational accuracy. At certain situations, it will show a different value, and at certain situations, it will show a different value. The veracity changes, and then the variability at various frequency you capture it. So as you have this data, which is big, and you store it, it's called the warehousing when you store it. And when you do computing with it, and you do data engineering, you check what is happening, and then data mining when you do, there's a lot of thing that goes on with the data. because it goes through a lot of people, a lot of machines, and a lot of places. So there is a possibility that this data can be used or misused or manipulated or even get forgotten, like hushed. So how to handle all these things is called big data. So this big data is a more important form for an aggregated data to be analyzed, and then you get an enriched data for an informed decision. If you want to do this, what happens is there's a lot of things the machine cannot do by itself. So you need to program it. See, this is where we call it as the coordinates of a big data. One second. Yeah. This part is where I said PW is the warehousing, where you store it. Big data is stored in RDBMS. It's called Relational Database Management System. This is one part where you can get to know about it and you can get interested, you can learn about it and do it. Where the data is being investigated and visualized. This is the part which happens in a data warehousing, where the data is either used or misused. So you need to be cautiously handling what has to be protected in the data. And the next stage is the data computing stage, where people, if there's a more chance of getting used, but there's a chance of misusing and also manipulating when you compute. People, they do a process, they store and they retrieve it. When this kind of factors happen, then the data computing is an important part for having a second chip. And then the data engineering, you go into it and you create a table, you make it into a model or whatever it is. That means you extract, transform, load, and create it into different forms. When you do that engineering, the same thing, it can be used or misused, manipulated, or even you forget it because you don't require it. Where then comes the part of data mining, which is the more important part, where you go on with extracting, discover, and reasoning. This is the part which goes on DM, where you apply a lot of logics, you go on start studying a lot of patterns, you see the opportunity, and you also hack into it and learn it, how things can be happen. So all these things are going to in a big data. When you want to have a machine with this kind of a features and it is in a position to take you through an advanced format, then means you need to have an algorithm. The algorithm, which I said, the programming part or the formula part, like, what and all goes into it. So there is something called algebra, whatever polynomial, non-polynomial distributions we study. And then the spatial measurements, your length measurement, your length, weight or mass, and your time. In case of electrical things, your current. In the case of thermodynamics, your pressure, volumes, temperatures. All these things are spatial aspects that happens. That can also get into it. Then the metrology aspects, like you have a lot of areas to be covered, volumes to be covered, and all this stuff. This is called the metrology. And the bioinformatics, that is what I sense, that can also be added into an algorithm. So if you want to have an algorithm, it is not a pure code, it is a mathematics combined with science. This is where the machine goes on getting tagged with a human dependency, and it functions. When it becomes artificial, what happens is it takes the data, the big data, and it processes with the earlier part, which I said is the algorithm. In this, it also puts its part of past experience, because earlier experience is also a data which is available in the machine. And then it works on adjustment or scalability to show it is brilliant enough to function in alignment with a human being. That's called the artificial intelligence. Otherwise, it's a pure machine. This is intelligent because it takes care of all these things and it functions as per the requirement of what we want. Now coming on to the two nitty-gritties on which this total webinar is focused, that's machine learning. Machine learning is an artificial neural network. It means it is going to have a lot of things which is connected onto a network, like how we have in our brain. Okay, and this network, it is seasoned in such a way that it applies from the artificial intelligence, our previous learnings. Everything is automatically taken by the machine. And every time the machine stores this data and it improves from its experience. This is where. And the speciality of this machine learning is it doesn't require you to program it every time. It does, its programming without your explicit indulgence into it. This is where the machine becomes intelligent. It has the features like interactive features, data mining, and chatbot. Interactive means the machine will show you a lot of graphs, charts, maps. This is this. Features is it will link a lot of models it can create for you, and it can do a timing aspect. It can do a deployment. Who can do what can be done? Everything can be featured. So it makes you clear what kind of a skilling is required to handle it. And then the data mining comes. It goes with your hyperparameters, cluster programming, the classification regression, time series, whatever it is. You get in with anomaly detection and all the stuff, and then it gives you an output. Either it can be on a voice base or a text base. So you can give a digital output, input and output, or you can have a voice input and output. So the machine is the one, such machine is the one which is called as intelligent, and this is being evolved, and that is the one which is going to be talked today. As we go further, then comes the deep learning. Deep learning is where I've already told you it is going to be linked to the human being. So when a machine learns, you can have a normal linear network, but this network is going to be on a multiple layer. It will have a lot of things. We think something, we speak something, we have a different feel for something. So everything has to be, all data has to be connected. And this is not in an algebraic form or anything. It is a non-polynomial activation. So you have this deep learning from a different sensory input that is to be taken. And then the hidden layers of unbounded width. You have a lot of data that are still stuck inside. So you need to cull it out and use it, because your information receptors are here, your vision, your smell, your speech, your sound, your touch, and your taste. Everything is being convoluted into it, and then it recognizes, it probabilistically analyzes, and then translates. So the machine has a real brain, which makes it, in addition to its own form of machine learning, it becomes more intelligent in terms of its sensory inputs being connected to it. This is where the deep learning comes. So you'll be amazed when the deep learning and machine learnings are being connected, how to handle these kind of amplifications or adjustments. Sometimes human beings know which is right, so we do. A machine does not know which is right. It does what is being programmed. A machine does not do wrong, because what you have programmed is what it reflects. So you have to adjust it in such a way as to do it. And then the novelty, like where it can do better, those things have to be controlled. And these data are being put into the memory of the machine, which is called LTM, STM. The STM is short-term memory, which is being put into a machine, becomes a long-term memory, and the machine keeps on functioning, whereas a human being has limitations. Whatever is on our short-term memory cannot be taken unless it is revoked by a kind of a impulse that has to push us down to make us come out with a new kind of a thinking of the past. So this machine is now intelligent, and it starts. So these are the sensors. You have vision sensors, smell sensors, speech sensors, sound, touch, taste, and titrator sensors all around. So let me not get into it, because it is more applicable only when you get into such kind of a projects. So where such project, each sensor is gone with the requirement. See, human beings are more sensitive and intelligent because we use already certain tools with us. It's called the OKVS tools. Organizers we use. We use a lot of calendars, schedulers, reminders, alerts, alarms, all these things we have. Knowledge sources, if you don't know, we can plug into a Google, a wiki, or go into a library. We can search and we can find out. Similarly, visualizations, we use a lot of graphs, maps, charts, dashboards while driving our vehicles and all the stuff. So we know whether we are going fast or not, going slow. So we decide certain things based on certain kind of a visualized inputs. And then there's more important part is an expert opinion. We don't know, but we can fall back on somebody else who knows this. And so that then astonishing breakthroughs can come, new pathways can come, and surprisingly new researchers can come when we involve with more people through networks. Similar things along with signs, symbols, gestures, sounds, and signals, if it can be handled, given to a machine, then the machine is surely going to be more intelligent than a human being. So this is the path on which the total world is changing through. These are the things: electrooculogram, encephalogram, dermal activity, and now you have myogram, all these things. Oculogram is, when you see certain things, your eyes goes to what you like. It's so when we watch your eyes, we can easily understand your observations, where your perception goes on, where your attention is going on, so that can be controlled. If a human being can be watched for his eye, then means the machine can understand and deliver. Then the brain activity, whatever happens in your mind can, if it is logical and it can be sensed, then the machine can also give you a better part. And the dermal activity, the skin galvanization. When we are happy, our skin is in a better reflex, and it reverberates in a nice way. But when we are hiding something and we get stressed and there's a tightening of skin, all these things happen. So the dermal activity, if it can be observed, then it can give. And a lot of things are expressed through our face, which is the facial recognition. If a machine can understand what we see through, or it can see through from our face, then it can really give us a better part. So there's a lot of sensing tools which are being now connected with machines and how it's being done. So now coming on, if you want to get in such kind of work to be done in the future, what you need to know? You need to know a lot of math skills. You need to get into programming skills. You need to do data engineering skills. Then the ML and DL algorithms. You need not go into everything. Pick something which interests you, which you are confident of taking your life further. There you organize yourself and do it. I've just drilled down so that you can, there's nothing forcing you to pick all the skills. Okay. Now, then the next part is each of this. If in maths, what to be learned? Probability and statistics, linear algebra and calculus are the more important part. If you are into a math student or a statistics person, then you try to get into these kind of inputs so that it can help you out in evaluation for your future. If you are into programming, Python is more important for ML DL programming, along with Java, and the basic R programming and C++ programming can also help you get a job which can get into this kind of activity in your future part. The data engineering here. See, the data engineering is, all of us use computers and we work through. So when we work through a lot of computers, we have a lot of data. Similarly, this big data is stored in different forms. So this data is formed in a big data, which is called as MongoDB. It's a program which you can understand. This is a language driver. MongoDB is nothing but a database, application database. This is connected to the application driver, which is called the Hadoop. Hadoop is nothing but an SQL, a structured query language, which can interrelate the storage and the data set, being stacked in various hardwares. It will pick up. And then these two are connected to a pluggable connector, which is the one which is going to create this data, the total big data to become alive. How it does? See, for example, you don't know anything and you're going to query in a computer. You open your screen and you click on the URL, the code. I want to go to this place. Then it picks that string is being broken down into certain words, and then you have each of these words with plus, 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 and then the machine goes and searches its database. Like this, in big data, what happens is, there is here in this part, if you can see, a data node combined task tracker. Here, what happens is, whatever you type on the URL, it is captured as a picture. And this picture is run down across the your data sets into your hardware, and then it captures. So big data is more safer compared to any other kind of a querying which happens in the current existing databases. So this is the data engineering skill. So if you want to get into this, how you have to get in, what motivates you to push through and get you into a kind of an employment. So the next part is, everyone can have a job. People need not be afraid that my job is going to go. It's industry 4.0 is going to pick out or push me down when I don't have the real skill. There are things like data pre-processing, like what our ITES organization does. You do a cleaning of data, parsing of data, correcting a data, consolidating a data. All these computing skills go on. Still, it will be there. Then comes the database, your existing MySQL, Oracle database, and your NoSQL. All these things will still continue along with your MongoDB. Then the higher end part is ETL, where you extract data, transform, and load. This is where each of this will be going on with a machine requirement, and it will be called as a higher end, where you will have more salary also connected to it. So if you want to get on with this kind of an employment, what requirement is, because everyone has now started learning and literacy levels have gone up. So master's degree is going to be a major part on which it'll be a ceiling cut. And you will have to have a multidisciplinary kind of an education, like computer science requirement is there. Statistics, electrical, electronics, mathematics, and pure sciences can also be covered into it. Others who doesn't have this experience, but you have an experience in artificial intelligence can also be covered as an educational level. So here, along with this, a computer knowledge, Java or Python. Python is more important, then C++ is required. I'm not going to now touch you upon ML and DL algorithms because my team, our friends are going to connect, cover that in the later part. This and the deep learning framework. Algorithm is what you program. Framework is how you structure. Deep learning goes with, these are the things which are already available in the market. Secret is there. Secret goes through your graphical models. It creates, and then it sequences and it gives you a predictable data. So when you want to do modeling, you can pick this for a deep learning network framework. And then Theano is what it does is, it does a defensive check. When your data is right, wrong, and debugging, everything happens. So Theano can be used when you want to have such kind of a deep learning framework. The sensor flow, the tensor flow is where you have the data flow itself. It goes with doing the differentiable programming. It does the auto differentiation. It does a GPU, graphical programming unit. It gives you a pipeline of all those things which has to be loaded or pre-processed or pre-fetching. Everything can be done by TensorFlow. That is the framework which is also available in the market. Then the Python-oriented PyTorch, which is having both. Like Scikit went with models, but PyTorch can also go with coding. So PyTorch can go with coding and modeling, and it does the computation and does the GPU supported like a TensorFlow, so that the hardware acceleration takes place. So PyTorch can go on. The next part is the Keras. Keras is nothing but a Python API, application programming interface, where what you have a high-level kind of a neural sensors. This is completely on a Python library, and it goes on with a real-time data augmentation and callbacks. See, all these things are for abstracting. If you know a machine can do this, and if you want to do it, you have to know in mind what can be done, what to be pushed. So you need to have a hammer when it is to be a hammer, and a knife when it is to have a knife. So the abstraction goes on with the generic functionality. So this is where the deep learning comes. But all these things are not currently being available in all the universities. This is happening across the industry, but the universities are waking up now. The future, another 5 years from now, sure, there's going to be a lot of courses coming out with cognitive science, which is going to be multidisciplinary, not then interdisciplinary. One, every engineer would be studying or biology, computer science, and neurosciences, because the demand is on your mind. You need to know what is happening in a mind, learning, the inference that can happen, the concepts and the activities of a mind, along with the artificial intelligence, which you're going to build in your machine learning into a machine. See, the trivial thing of a mind is, we express some things, we control some things. Only when we express, it can be programmed. When we control ourselves, no sensor or nothing can be controlled. Come out with a nice opportunity to function for you. So human beings have to be such open enough when they do the programming of the thoughts and feelings, what they have, and they intend from a machine. When the consciousness is happening and the thoughts are being right, then the machine can function well. And similarly, when the feelings, when the expressed part, which is unconscious, then the feelings can be right. The other way, like if you control yourself and you position even in as a conscious emotion, that means you're only acting, and the machine is going to do only wrong things for you. So you should know how you can interpret the sensors to make the right choices for you. See, be whatever it is, ultimately, whatever we study has to be pushing us for an employment. If things have to be gone for an employment, one second, I've typed the wrong part. The last part is, who is going to employ you? Right from Microsoft to Qualcomm, everyone is going to employ you. There's a lot of things with Amazon, Intel, Google, Apple, IBM, NVIDIA. The Meta, FB has changed its name to Meta, Facebook. then the sensory, all these companies are of a great demand. I wish our friends who are listening, if they can pick up these skills, then when you go abroad, go to US or go anywhere across the world, or do something as a an entrepreneur in Africa itself, you can mint money, and which is going to be very great for generating employability to a great mass of people. With this, I end my speech. Thank you all. If there is any questions, you people can ask me.
Thank you, Umachandran. Thank you, Umachandran. It's really a nice speech, and you have covered the entire architecture of Industry 4.0. From sensors to IoT, you have covered everything. So even I will touch upon the employment opportunities and everything. And based on that, adding with the Dr. Umachandran, just I want to add up. So you people, the students from Africa and other members, you have to touch upon, you have to start from the sensors. You should learn various sensors available. And also you should know the application where you're going to apply. So the initiative you have to start with, because you're going to pick the data only through that sensor. So you need to select, because I am in a teaching profession, the students are doing a lot of projects, but before that, what sensor they have to select for particular application. That is the most important part. So after that, you have to add up based on Umachandran's talk, like you have to go with sensoring the data and transferring the data, and finally you have to go put into the machine and intelligence, and finally IoT can access. So all these networks really nicely covered. Really appreciate the excellent talk and the excellent coverage of everything, all the elements in the Industry 4.0 elements. Today we got Industry 4.0, around 11 components are available. Even augmented reality, virtual reality, there's so many things. So with this, I request the audience to ask, it's open forum for a question. You can ask the expert any type of question. So he's ready to answer, because he's an industrial experienced person. He got a very rich experience on both theory and practicals. Audience, please.
Professor Gopi, your camera is off.
Yes, sorry, sir. Yes. Audience, please. You are welcome for the question.
Thank you. Thank you, Dr. Umachandran. Can I ask my question now, please?
Yeah, go ahead.
Yeah,
go ahead.
Yeah.
Okay, thank you. Well done for a wonderful presentation, Dr. Umachandran. For me, machine learning is entirely new. And with this presentation, at least I can say something whenever I find myself in any setting. So, but I wanted to ask, for Python programming, we have a platform. Either you use any code editor like any IDI like Anaconda or PyCharm. And for if you are dealing with geospatial analysis and modeling, use the GIS. So is there a platform that to GIS, say ArcGIS or QGIS or any other open one or commercial one that we can also use, or on what platform do we host machine learning? I don't know if you get my question, Doc.
Thank you, Olentia and Andrian. Thing is, see, Python has now released to four versions, and the fourth version is currently in vogue. Up to 3 versions, you need not go and study up to Python 3. You can jump directly to Python 4. Python is so open, you need not know coding. You need not know even Java. But if you know Java, it will be good enough to understand Python more. That's all. They have a lot of inputs that can go on for open learning of people. So that is where the Python has a better impact or affiliation towards the future learners. So you need not worry about it. You need not know coding. You can get into learning Python 4. It is good. Adivali 5 day.
Yeah. Please come forward. You're not audible.
Yeah. Please come forward. You're not audible.
You're not audible. It is some disturbances there. And adding to Dr. Umachandran for the question raised by. Yes, please. I think some disturbance is there. We are not clearly audible. Your voice.
He can text it and I can answer it in the end of the session. No issues.
Yes. And sir, adding to Umachandran sir answer, the Wellington on it Adeniran. See, the PyCharm you asked, PyCharm and Anaconda. That the platform, the PyCharm and Anaconda is the API. Actually, the PyCharm is the API. You can very well easily download it from the freeware. And also one thing I want to tell you for you people, one lab is the CoLab. CoLab is the Google lab. So through that, you can do Python, and the Python you can easily do it. Even 2 lines of Python, you can do it. That is one application that is a freeware is called CoLab. You can put it in a Google. It's a Google lab. There you can practice your Python. The entire information available. This is for additional information. Thank you. And any questions, please come forward. I think Adivala, Freddy, I think the voice is not audible.
I think the voice is not.
You put it in a chat box so that expert will answer your question.
We are also tied up with time. I will surely answer Adivale's Freddy's query. You just text it and I will answer you. Or in the end, I'll also give you my email ID. You can send your query.
Yes.
Next.
Then, okay. If any further question, you can ask me. Otherwise, I will move on to next session. And so, can I move, Dr. Umachandran?
Yes, please.
Thank you very much for your excellent speech on this. Okay, I really appreciate your the presentation, and I'll move on to next session. I welcome Miss Rajani Thakur, technical consultant, who is going to talk about history, what, why of machine learning and learning system model, training and testing, performance algorithm and applications and future scope. I welcome Rajani Thakur for your presentation.
Yes, thank you so much, Professor Gopinath. Just hello everyone, and just thank you for having me here. Just my name is Rajani Thakur. I'm a freelancer technical consultant, just working on Python machine learning projects, giving trainings in different colleges on the same technology. So today we are going to cover the topic that is machine learning. So what is machine learning? Why it is so important nowadays for everyone? How we can make our career in this particular vertical, so in this particular domain. So we have seen machine learning as a buzzword for the past few years. So now the reason means, what is the reason behind that we are most talking about this today? So just going to start, I'm going to share my screen. Please just let me know, just everyone can see the presentation.
Yes.
Yes.
Okay. So before going to start this machine learning, so we have to understand the artificial intelligence first. So what is artificial intelligence? Is a popular branch of computer science that concern with building intelligent smart machine capable of performing intelligent tasks. So we can say machine learning is the subtitle or subpart of artificial intelligence. So now we can divide artificial intelligence in 3 main categories. First is artificial intelligence, machine learning, and deep learning. So all the main part is already covered by Dr. Krishnan. So what is artificial intelligence? That is the theory and development of computer or a system able to perform tasks normally requiring human intelligence. So that is the main reason to learn the machine to make smart aids, and the ability to learn without being explicitly programmed. So that is covered in our machine learning program, machine learning domain. And if we talk about the deep learning, what is deep learning? Machine learning algorithm with brain-like logical structure of algorithm, that is also known as our neural network. So we have to understand these three types of artificial intelligence categories. Next is our deep learning. So deep learning is a subfield of machine learning that is concerned with algorithm inspired by the brain's structure. So it is also your functional known as artificial neural network. So before just going to just cover all the topic, we have to understand the difference between the artificial intelligence and machine learning. So what is artificial intelligence? So here we can see computer acts on their own. It is with the help of artificial intelligence. They act according to the environment. System display cognitive ability and computers make decisions. So that is the main part of artificial intelligence, particular model. And if we talk about machine learning, it is an application of AI. Okay, so your machine learning is the application of your artificial intelligence. And the most important part is computer observe and analyze the model. Next is predict. So the most just important part of machine learning is the prediction. So it predict based on your previous pattern what the data you have feed it in the model in the system. So we will use pre-programmed algorithm, and according to the algorithm we will get the result in the machine learning domain. So now just understand what is machine learning. It is a type of AI that enable machine learning to learn data and deliver predictive models. It is not dependent on any explicit programming, but the data fed into it. We are just cover machine learning. So who invented this term and who had already worked on the machine learning this topic? So Mr. Arthur Samuel in 1959, so he had discovered a term machine learning, and he had introduced this term in the particular industry. So there is a category, or we can say there is a domain machine learning. We can use that and implement to grow our IT sector, to convert the digitalization in our just daily uses, machine or in every particular industry. So we can use predictive algorithm, will create a predictive model. So this is the particular content. So what is machine learning? Now just understand the particular workflow. So there is an ordinary system. We just, with the help of artificial intelligence, we just learn the system, and it will use machine learning algorithm. We learn the particular model, then it will predict the data which we have just given into the model, and with the help of feedback it improves and give our result with the accuracy. So we can say machine learning is the science of making computers learn and act like human by feeding data and information without being explicitly programmed. Now, what we give in the machine learning model? So first we have to classify the data, and according to the data, we going to make the prediction on that. Now, most important topic is why we learn machine learning in today's life, where we can use it. Suppose you are going to drive your car without you, and with the help of machine learning, with the help of machine, you can detect more than 50 eyes disease with the help of the machine. And machine can unlock your phone with your face. So in all these particular segments, you can or we can just use the machine learning models. Now just going to understand the structure of machine learning. So what we have to cover all the particular stages to learn the machine learning particular models. So first we have to define the objective, then collect the data, and then prepare the data to understand the format and quality, what you want, the characteristic of the data, then select the algorithm, just build the model using prepared data and evaluate the model. Then next part is train the model. Means you have to define some data set to train the particular model using some machine algorithm, which we will cover in our next slides. Then test the model, because testing is very important to just understand the result of the model, and then we'll get the accuracy that will be your 70 to 80%. It depends on the data which we had fed it into the particular model. And now the use of the algorithm, it will predict the particular outcome with the highest accuracy. So after getting the just particular results with the highest accuracy, now we are just going to deploy the particular model where we are going to just require, or we are going to deploy. So all these particular stages we have to cover whenever we are going to cover any project on machine learning. Now next is, what is the type, means what all are the types of machine learning. So first is your supervised learning, unsupervised learning, and reinforcement learning. So what is supervised? That enable machine to classify, or you can say predict object problem based on label data. So your important part is label data. So you can fed just label on the data in the supervised learning. And if we talk about unsupervised learning, there is you can say unlabeled data set is there. It only supervise the pattern, the behavior. Okay, so in unsupervised learning, it will just supervision your behavior, your character, your particular pattern. It will just work on that. And if we talk about reinforcement learning, so this model learn how to behave in an environment by performing action and seeing the result. So these are the category in machine learning to understand, or you can categorize the particular just model in these three particular categories. So with the help of this diagram, you can easily understand the difference between your supervised and unsupervised learning. In the right side, you can see unsupervised. So there is no label data. And if we talk about supervised, there is a label data. And in supervised learning model, there is always a direct feedback. And if we talk about unsupervised, there is no direct feedback. And if we talk about the supervised learning, there is a predict output. But if we talk about unsupervised, there will be a hidden structure in the data. So this is the major difference between your supervised and unsupervised learning model. So next is we can just segregate your machine learning supervised or unsupervised learning model into three different this particular segregation. First is your classification, regression, and clustering. So what is classification? So suppose if you want to predict a category, suppose you want to predict a category, then you have to just use the classification category. Suppose you are going to just use any prediction in the stock market. So it will comes under classification category. And if we talk about regression, suppose if you want to predict any quantity, any age, height, weight of a human, then it will comes under regression category. And if we talk about clustering, it will always discover the structure in unexplored data. Suppose there is a different type of customer with similar behavior has been given in a large database, and you want to segregate the information according what they had bought. So you have the buying records, you can segregate or you can classify, you can just differentiate the data with the help of clustering. So these are the three most important categories. So suppose I'm just taking an example to understand how machine learning understand or just get the data and how it can predict the output. Suppose we have given information to the system, to the model. I have given information Venus. So just 1 minute. Yes. So we have given an information of Venus. We have just entered Venus has a beautiful name, but it's hot. Second information we have passed into the model Mercury. So Mercury is the closest planet to the sun. Now we have just passed some more information in the particular system. So we have just passed information of Mercury, Earth, Venus, and Mars. Now, just next time, if we want to know the information about Saturn, okay, so it will just predict that it is also a planet with the help of other information which we have already passed into the model. So this is the prediction means with the help of the machine learning. So first we have passed the information of Earth, Mercury, Venus, Mars. Now, just if we want to predict about the Saturn, then it will comes out with the information. Yes, Saturn is the gas giant that has ring. So that also just predict by the machine which we have already passed into that particular models. Now, just next important thing is the history of the machine learning. So in 1950, the simple algorithm was invented by Mr. Alan Turing. Then 1960, Bayesian method was introduced. It is totally just on probabilistic inference in machine learning. And in 1970, there is an AI winter caused by pessimism. So this is an era from where the machine learning is started. So if we talk about the current scenario, so in 2017, there is an AlphaGo, that is a computer program, defeated the world #1 player Key G. So this is the complete era, means this is the particular, all the invention has been happening from 1950s to till date. So your deep learning popularity has been started in 2010. Your support vector clustering that was introduced in 2000, and data-driven approach was also just introduced in 1990s. So this is an history of machine learning, so which we have just seen. Now, the opportunities where we see where we can use the machine learning. We can use machine learning in image recognition, voice recognition, optical recognition, customization, data analysis, and memory data. So all these particular domain, we can use the machine learning to enhance the property or to get the best benefit from this. Now, to work on machine learning, we have to understand the different algorithm first. So what all the algorithms are, like your linear regression, logistic regression, random forest, Knn algorithm, K-mean clustering, support vector, machine decision tree, naive Bayes classifiers. So all these algorithms are used in the particular machine learning to get the output, to get the predict information from the model. So first is linear regression. What is linear regression? It is a linear model. So you have already studied in maths, there is a linear equation, right? So it is, you can say linear regression is a predictive model used for finding the linear relationship between a dependent variable and one more independent variable. To understand this line, y equal to a plus bx. So here y is a dependent variable on this particular data, a plus bx, right? So in linear regression, you have to always understand the value of your dependent variable and independent variables. So this is the relationship, just understand the relationship between these two particular variables, that is known as your linear regression. The next is logistic regression. What is logistic regression? That is used for predicting the category dependent variable using a given set of independent variables. So there is no such as data. So you have just in this particular algorithm, it will predict the behavior, the records, the past records of a customer, of a player, anybody. So it can be used to predict whether a political candidate will win or lose an election. So it all totally work on the past records. You can say the performance of that particular candidate, performance of a company. So you can predict just company productivity, pricing. So all can be done with the help of logistic regression. So we can say the dependent variable has to be categorical in nature. So the number should be there, right? The next is random forest. So what is random forest? It is a popular machine learning algorithm that belong to the supervised learning techniques. What is supervised? We have learned we will give some labels in the supervised learning. So it can be classified into categories, classification and regression. So simply we give some training set and test set. There will be decision tree. So it will take the decision according to the data we have passed. So with the help of averaging, with the help of voting, the prediction will be out. So random forest is a classifier that contains a number of decision trees on various subset of the given data set and takes the average to improve the predictive accuracy of that particular data sets. So this is the use of random forest in the machine learning. So most important point for all the student or for everyone is what algorithm, or we can say which algorithm we should use in which scenario. So you have to understand the USP, or you can just understand the particular behavior where you can this particular algorithm. According to that only you can choose the best algorithm according to the requirement. So next is your Knn algorithm. So it is also some just important, or you can say interesting in the machine learning. Knn algorithm assume the similarity between the new case data and available cases and put the new case into the category that is most similar to the available category. So suppose there is some data already fed into the in the model. Okay, system means model here. So don't be confused. System means the model. So we have given an input like cat. Okay, so now the model will check. So it will check the behavior, means characteristics, and then it will predict and let you know. So this is the particular input value is like a cat. So Knn algorithm store all the available data and classify a new data point based on the similarity. This means when new data appear, then it can easily classified into a well-suited category by using Knn algorithm. So we can say here Knn is a non-parametric algorithm, which means it does not make any assumption on underlying data. It only give you the output whatever we have already fed it into the model. So it will just not give you any assumption on their own. So whatever the data or just input already just fed it into the system in the model, then only it will give you the predicted output. So next is your decision tree algorithm. Your decision tree is a tree-shaped algorithm used to determine a course of action. Your each branch of the tree represent a possible decision, occurrence, or reaction. So suppose there is a particular decision node. Again, it is divided into two different decision node, then you have to choose which one is just better according to the requirement, according to the output, then you have to select that only. So decision tree is a supervised learning just technique that can be used for both classification and regression program, but mostly it is preferred for solving classification problem. It is a tree structure classifier where your internal node represent the feature of data set and branches represent the decision rules, and each leaf node represent the outcome. So this is the total overcome to understand what is decision tree algorithm, how we can use in the machine learning. Now next is just understand the k-mean clustering. So clustering means the group, right? So k-mean clustering is an unsupervised learning, means unsupervised means there is no any labeled data, unlabeled data is there. So in this particular algorithm, your groups the unlabeled data set into different clusters. So you can see here there is a graph. Here is different dots are available. With the help of k-mean algorithm, it will just make different groups of the particular data set with same behavior, with same property. So this is the use of k-mean clustering in machine learning. Next is your support vector machine. Your support vector machine is one of the most popular supervised learning algorithm. Wherever you just see the term supervised means labeled data will be there, right? So it is used for the classification as well as regression problem, or you can say SVM algorithm can be used for face detection, image classification, text or text categorization. So here we can see we have given information of cat and dog. So we just train the model and just now predict whatever we have just given the new data in the system. It will check the past information we have just inserted in the model. With the use of support vector machine, it will give you the information that it is a cat. So this all the thing is happening with the help of support vector machine, which works on images. Okay. Next is our naive Bayes algorithm, which is a supervised learning algorithm, and it is totally work on Bayes theorem and is used for solving classification problem. And yes, it is come from your naive and Bayes. Bayes means it totally depends on the principle of Bayes theorem. And naive is because it assumes that the occurrence of a certain feature is independent of the occurrence of another feature. And you can use this particular algorithm in credit scoring, medical data classification, real-time predictive, and other just spam filtering and sentiment analysis. So we can use naive Bayes algorithm in these particular tasks. Now just look at this particular slide, machine learning uses. In supervised learning, we can use in classification problem like fraud detection, email spam detection, diagnostic, image classification. For your regression type of problem, like your risk assessment, score prediction. So we can use these particular supervised learning model in these particular problems. And if we talk about unsupervised learning, so in the reduction, your text mining, data visualization, face detection, voice detection. So, and if we talk about the regression, your city planning and targeted marketing. So all are based on the behavior on the, means it totally on the unlabeled data, and your supervised learning works on the labeled data. And in reinforcement learning, there is in finance, manufacturing, stock management, autonomous car. So we can use machine learning here to predict the market. And the future prediction means how much will be hike or your in this stock management, all the information you will get with the help of machine learning. So here are some more application you can use machine learning, your like spam filtering, mobile banking, your risk assessment, social network. And now, just in these days, you can see anyone just is going to comment on Twitter, on Facebook, any on social media. So with the help of feature engineering and the classification algorithm, it will notice and let you know. So this is the comment related to polite category, and this is an offensive comment. So all this working is happening with the help of machine learning. If we talk about in medical industry, so we can diagnose disease more, drug discovery and biochemical analysis will be done with the help of machine learning. And now we can see the different application where we use the machine learning, like your chatbot system, decision support, customer recommendation engines, customer churn modeling, pricing strategies, customer segmentation, and image classification. So also you can see in the right image, so your speech recognition, traffic prediction, product recommendation, your automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, means everywhere you can see the use of machine learning. So next is, we have to always understand the advantage and disadvantage of that particular technology. So if we talk about the advantages, the efficiency of data managing is there, continuous improvement is there in the machine learning, lot of applications is there, trend identification, pattern identification is there. But if we talk about the disadvantages, your data acquisition, because we get data from different sources, from different platform. To integrate, to clean that data, to merge on a single platform, it is not an easiest task. So it will take time and space, time consuming activity, and yes, high error possibilities there. If your high error data is there, then you will get high error your prediction or output in the last. And yes, algorithm selection is also an you can say a hectic task in the machine learning, so it will take time. Now just understand, if you are going to take a chance, take a job in the machine learning, so there are a lot of questions is given or is asking by the interviewer with the student, with the people on the machine learning. So here are some important questions, just you have to overview on that. So what are the different type of machine learning? What is training set, test set in machine learning model? How much data will you allocate for your training, validation, and test set? And your next is, how can you choose a classifier based on a training set data size? What are the application of supervised machine learning? Difference between supervised, unsupervised, compare your all the algorithms. So all are the important topics you have to learn. You have to just make sure the basic information you already have about the machine learning. And yes, already Dr. Krishnan just brief you on the Python. Python is very important and everyone can easily understand. No prior coding experience is required to understand the programming. Just go on, just download your Jupyter, your IDE, different IDEs available right now. So your Jupyter, PyCharm, or your, yes, Professor Gopinath already told about the Google Colab. So it is a very, we can say, user friendly. So you can use that, and the basic information or basic practice you can do on that platform. So that is the complete information from my side, the basic theory. And we learned about what is ML, all the important part of the machine learning. And I have presented you with the basic concept of machine learning. And I hope this webinar is helpful and would have motivated you enough to get interested in this topic. Just thank you so much.
Thank you very much. Thank you very much for your excellent information about machine learning. Right. Really, I hope the audience would have received very good information about difference between machine learning and artificial intelligence, and also different types of machine learning. And finally, end up with a very good question, which is normally asked in an interview. Very nice of you, madam. And any audience, please raise your question. Already, I got one question, madam. That is from audience. How do you apply ML and DL in food industry? How do you apply machine learning or deep learning in food industry? It's already posted in the chat box.
Can we take the questions later, Professor?
Okay. Yeah. Okay, then we'll proceed with the next session. Can I proceed? Next session?
Yeah, go ahead.
Thank you very much. Thanks the audience. I'll go to the next session. I'll call upon
Professor,
Dr. Varalatchoumy.
one small request.
Yeah.
Professor Joshua has some urgent rush. Can he complete it and go?
Yeah. Joshua. But I don't have profile. Okay, anyway, just you introduce Umachandran, please.
Yeah. Professor Joshua is from the Northwest University. He's from the Computer Science Department. He has been a great, vocifier of, Industry 4.0. He has been conducting a lot of conferences and publications on that. Let us hear from him because he's having an urgent rush to be done. Yeah, Professor Joshua.
Okay. Good morning, good afternoon, and good evening, everyone. Yes, please let me share my slide. Then, thank you, everyone, and then for this opportunity. My name is Joshua Chukwuere from the Northwest University. Yes, thank you, everyone who has presented earlier. I think they have said a lot about machine learning and what it can do for us in a present world. Remember, our world is changing and it's changing so fast. And technology is becoming a kind of a handy tool in all the change that is taking place today, be it from natural disaster and so on and so forth. And machine learning comes in now when all these changes are taking place to make life better for the people. Now, when we look at the changes in our world today, social media is playing a lot of significant role. And within that very opportunity that has been run from social media, fake news flies. And it is impossible for human to understand, to detect fake news, both on the printed media and our conventional media and the social media. And because of this, machine learning comes on board to bring relief or solution on this whole thing. Now, fake news is no longer a joke, but a reality that affects every sector, different sectors of life, individuals included, and government. And when you look around, they're in different countries. Government is putting different measures in trying to cope or to curtail the effect of fake news. And then putting different measures and then across different social media platforms to minimize the effect. But defeating fake news remains a huge challenge for individuals, government, and organizations. Now, the solution to this is where the fake news is playing a role. And how is it coming on board? and machine learning. And why do we need, why is machine learning coming to bridge up this very challenge? As we have learned so far that machine learning is part of AI, artificial intelligence. Please, please pardon me for that error. Artificial intelligence should be AI, not IA, please. Its use is a branch of AI used in data analysis. How to be able to analyze, to understand a component of data set, be able to read it, to analyze, to understand what is within. So you find out that as we have known it, that so far that machine learning system learn. How does it learn? It learns from what? Existing data. There is a whole lot of, the last speaker made mention of that there is a whole lot of data everywhere. And then the machine learning is able to pick from those those data, and then be able to make sense out of it. So from the collected data, it identifies the behavior, the pattern, and then make decision with little or no human intervention. And that is what makes it unique. And now within the line, within the space of social media, and then fake news. We know that social media provide the opportunity for users to communicate, share information, share content unsupervised. What you share today on social media, no one is supervising it. No one is editing it. No one is, this is unregulated world of information. And that is what makes social media to thrive on it, because no one is editing what is being posted, no one is editing what is being shared, and so on and so forth. So it promotes positive and negative impact. However, this very platform, or these platforms in general, are fueling as a fake news. So, and this is a major challenge in our world. So now, the big question is this: how can fake news on social media be detected? How can we do that? Because human beings cannot do it. Because before you realize it, for you to understand that this very content, this very post is fake, it has spread wide and people have believed it. You can only believe it when you are able to hear from the reliable source after the damage has been caused. After you have read the full story, then you can understand it. So how can we be able to control this, to detect this? To do this, machine learning comes in. Remember, the ability of machine learning it lies on its will to be able to understand, to learn. Meaning what? That you need to be able to feed information, content to it. It learns with that very content, and then be able to understand a situation when it arises. Now, how can that work on social media? What it involved is this: to be able to teach the system, machine learning systems, on how they can be able to detect, giving it all different kinds of data concerning a particular thing. So as soon as fake one comes in, it can decode because it has been trained. We saw it through that mechanism, supervised and what? Unsupervised and reinforcement learning. As soon as you pass this, as soon as you pass machine learning system and the algorithm through this process, whether through supervised, unsupervised, and reinforced, it is able to do what? To detect, to pick as soon as fake news, information that is being pushed out on social media platforms. Okay. Now, as a part of social AI, it has the ability to imitate human behavior and action. The previous presenter have made it very clear that it can, through the prediction pattern ways, how does it predict? Because it's now you have feed this system what human can do, and then it can repeat it can reproduce those behaviors and those actions. So within social media, it can train itself to understand human behaviors, human actions using its method, all these different kinds of methods. So as soon as that happens, as soon as fake news comes out and pops out, it can be able to detect because it has been trained to understand the sequence, the pattern, the characteristics, the attributes of an information that depicts fake news. So this is being done through a classified means. So for machine learning to understand fake news, it can be done, which we're going to see in all those classified method it can use to detect fake news. Now, I'm not going to dwell much on this because our recent presenters have with it. But let's look at this. We have unsupervised, we have supervised, and we have reinforcement. Now, through this, it can be able to do what? To make prediction. Now, when it comes to on the aspect of unsupervised, you can see there is meaningful compression. In order to do what? To detect. It can be recommended system. It can be used to make separate, to say, okay, between A and B, this is fake, this is real. Okay, and then when you go over to supervise, it can, through your image recognitions and all the rest of them, and diagnostic ways and all those kind of things, that can be done. But the point I'm trying to make here is this, that we can see that the way machine learning has been built through its different types, it can be able to do what? When you train it across the board, it can predict this particular news that is flying, that is going on. Then it runs it through its system to say, okay, this news is fake, that news is fake. And when that happens, it informs you as a user to not to believe that this news is fake. Then what do you do? As soon as that happens, all the anxieties, all the stress that could have caused through that very news will be dissipated, because of what? It has informed the reader concerning that very news. Why do we need machine learning to detect social media fake news? Why we need it is because humans are challenged to detect fake news. And this fake news is a major challenge for everyone, individuals, organizations, government. So everyone cannot do it. But through the help of machine learning, that can happen. We need it because of what? The impact. Many people have committed suicide today because of fake news. People are running into depression because of fake news. The impact is quite huge in our society. Now, there is another reason why we need it, because it can assist to detect any kind of fake news information that can be found out there. Okay, so this is the reason why we need machine learning. What is the most suitable machine learning classifier that we can use to detect social media fake news? One of it is a logic regression. We have net bias, neural network, and so on and so forth. All this, which some are going to be asking a question: how can I personally be able to use these different classifiers to do this? And if I can remember from the previous presenters, it was mentioned that this can be done through programming. your Pythons, your C, your Java, your C++, and so on and so forth. That is how that can be done. It cannot just done automatically. It needs to be programmed, and when through the programming processes, that is very achievable. Okay. Now, how can machine learning be trained to detect this? The only way for this to be done, irrespective of any classifier that you use, training is what is needed. Nothing more, nothing less. You need to train all those classifiers, each of them to be able to do what depend on the one you want to use, because research has shown that each of these combination of them, like your support vector machine, can have the chance of predicting fake news over 70%. Some of them have the accuracy rate of over 90%, 80%, and so on and so forth. Now, that's to show that if it is being trained, you use any of them and you train it perfectly, it can read above 50%, which is great. But it's not just 50, but majority of all these classifiers can read 70 and above %. Meaning what? That when government, when institutions deploy machine learning on social media, then fake news will be detected. And that is it. Recommendation. Now, in all these things we have talked about, we need to make fake news on social media a priority. That is, there should be a great emphasis from individuals who are using it, from organizations that are using social media, that fake news exists. Invest in machine learning systems. There is a need for more investment on different machine learning systems. There is a need to train machine learning to understand the sequence, the behavior, the pattern of fake news. Then great emphasis should be placed on education. Users of social media should be educated to understand the consequences, the impact, the great impact of fake news on the people, on human, on organization, on the government. We have seen it playing across fake news on the political scene, on products, which those things are not true. So, but when there is proper education, you find out that people will be aware of this, that this, what I'm about to post can harm someone, can cause someone a great impact, negative impact. That person will be conscious of anyone can be conscious of what they post on social media. Finally, do not believe till you verify. Do not believe what you see on social media till you verify. When you see that very headline, don't believe it. Try to read the full story to understand. Remember that, and the literature have showed us that people who post, there are different reasons people post fake news. And one of the fundamental reasons that drive people to post fake news is to draw social media attention, to increase their social media traffic. So because of this, what do you do as an end user, not to believe whatever you see on social media till you verify from a reliable source, and so on and so forth. In conclusion, fake news on social media can be detected, mitigated, controlled, and being eliminated. The process of using machine learning to eliminate fake news on social media should be intentional. Let it not be something that just comes. Because when it becomes intentional, what happens? That investment will be there. Organizations will put their money to do something on it. Government will do something on it. Users, individuals will do something on it, will be conscious of that I'm not gonna post something which I can't verify. I can't spread something which I can't verify. Then because it's not been intentional process. And then being implemented across all platforms, whether Twitter, whether Facebook, WhatsApp, and TikTok, and all the rest of them. So the intentional part of it from all the stakeholders, individuals, organizations, and government. When we make this as an intentional something, that what we want to eliminate fake news on social media, we find out the process of implementation becomes very easy because you're aware of it that there is a danger of fake news. You're not gonna post it. I'm not gonna post. No one is gonna post it. And when we do this intentionally, automatically, we can be able to do what? To eliminate fake news on social media. Thank you so much for listening and participating.
Thank you, Prof.
Thank you, Professor Joshua. You are taking a very nice case study and explain it. I hope people would have got a very informative things and they would have started doing machine learning applications, searching for machine learning applications. Thank you very much. So now I call upon Dr. Varalatchoumy on the topic medical image analysis. She is from Cambridge Institute, Bangalore. Dr. Varalatchoumy, madam.
Yes, sir. Sir, I kindly request Dr. Joshua, sir, to stop the screen. Yeah, thank you. Let me share the screen first. Hope the presentation is visible.
Yeah.
Thank you, sir. Yeah. So good evening, one and all. Thanks for the wonderful opportunity to share my knowledge on medical image analysis using machine learning. Thanks to all the wonderful speakers for sharing the basics of machine learning, artificial intelligence, various algorithms involved. And in the previous session, we have gone through a specific case study on fake message detection. That was wonderful. So in that aspect, we wish to continue with one more specific application, of course, with a case study also, wherein we find the application of machine learning to be tremendous. So that is medical image analysis. So nowadays, we find machine learning playing a key role when it comes to image analysis. So there are so many medical experts, radiologists, and physicians who literally need the support of machines, or rather our computer systems. Through machine learning, they need the support of the systems in order to do several predictions. So what are all the advantages, or why do they prefer these technologies? What does it do? So it is something amazing because it is going to support the experts in diagnosing the diseases in a quite earlier stage and in monitoring several medical conditions, and not only just monitoring, but also to take ahead with the treatment. Like patients need not undergo severe test or very painful test and all. So through the images that has been collected itself, it will be easy to predict what is a condition or what is the severity of the disease, what is the treatment that has to be provided, and what is the effect of the treatment with respect to that particular disease. So the second point highlights the same. It is totally non-invasive. Non-invasive means we are not going to penetrate or inject several chemicals, or the patient need not undergo surgeries even to predict a disease. So gone are those days wherein patients have to undergo some difficulty in order to first literally predict what the disease is. And all of us are already aware of several imaging procedures. So nowadays, if you see all these procedures, be it X-rays or MRIs or CT scans, every particular procedure is associated with machine learning. So we make use of machine learning in order to identify the diseases in a better, an earlier stage and in a better manner. So with respect to medical image analysis, why do we have to analyze a medical image? We have an image. We, of course, our experts, we would have seen the clinicians or the physicians just visualizing the image. They get an idea about what is there. But what about this analysis? Why do we have to go with the analysis? So one main thing is we need to come out with a quantitative measurement. I would wish to highlight example for this quickly. Okay, very soon I'll be going to that slide. That time I will correlate this. What is a quantitative measurement? The interpretations, what we try to get, what we try to infer that particular from that particular image. And next important thing is the experts or the physicians' prior knowledge is going to be integrated through the algorithm. So we have seen Ms. Rajani explaining several algorithms. So the prior knowledge means experts, the medical experts already know if these are the symptoms, there are possibility of this disease existing in a particular patient. And not only that, even the theoretical proof. So all these things becomes a prior knowledge in order to train our machine. So the experts, the speakers till now, they have told any machine has to be trained. Like it's almost like a child. A child doesn't know what it is. For example, if you take a fruit, see, from our childhood, we have been wired. We had been told multiple times, something which looks like this needs to be called as an apple. Let me take this example so that it will be easy to understand the concepts in the next following slides. So whenever I see something which is edible, something which is tasty, which is red in color, in this particular shape, it has some seeds inside, X, Y, Z. So goes on. So from our childhood, we have been told that such thing has to be called as an apple. In both the ways, they have shown some image. Multiple times they showed the image of an apple in front of us and they made us tell this is an apple. Similarly, they made us feel we had an apple, and when we were eating apple, they kept on telling this has to be called as an apple. The same thing applies over here. So mission is like a child. So what you feed into the mission is nothing but the training part. So through our prior knowledge, with whatever information we have in hand, we can go for training our mission. So through that training, our mission does the predictions. Sorry. Yes. So why medical image analysis? So as I was mentioning just now, it will be helping a lot for the medical experts to get a very clear picture of what is happening inside a patient's body without the patient being forced to undergo any tremendous testing or any particular difficult tools being inserted inside the patient's body. So the understanding of the medical condition goes easy for the expert. And next important thing is with respect to the radiologist. I wish to highlight this point because my research was oriented towards earlier detection of breast cancer, the stages of breast cancer. So that being the case, a radiologist, like through the several images, the mammographic images, though a radiologist gets to know that this particular tumor, this particular region can be predicted to be malignant or benign. Benign ones are the ones which doesn't cause any harm to the life. It is not life-threatening. Malignant is totally life-threatening, which has to be treated as early as possible. So that being the scenario, when machine learning comes into picture through the algorithm, the experts get a better idea. The radiologists get to know, is this is exactly the tumor which is malignant through the images itself. That is quite challenging. But when we were able to achieve this, it was something amazing because the patients need not undergo biopsy multiple times. They need not undergo they need not, get injected with some chemicals multiple times. So this was really reducing the stress level of the patients. And if you just visualize the X-ray image, what I've shown on the right-hand side, there is some meaning for that. Those things which are being inserted into the patient's body. For example, this was something related to the bone fracture. So this particular portion, what was inserted is called as an implant. So this was one of the project which was given to us by an hospital, wherein the ortho doctors, the surgeons, their request was like, this particular implant, okay, what we visualize, it looks so simple. The implant has to be fixed, fine, but it has a lot of impact at the back end. This implant, that particular structure, the size of the structure, okay, it can't vary even in point, not one particular unit. because it's going to create a problem for the patient. If it is slightly on the higher end, it pierces the body of the patient. If it is on the lower end, it doesn't do the task which is expected to be done. It doesn't cure the problem. So they want a very perfect measurement. This is something what I want to correlate with the quantitative measurement and interpretation. So that's very important. So how best we try to come out with the measurement, how depth is the fracture, to what extent it has gone inside, what is the thickness, so many things has to be measured. And just imagine a machine learning algorithm doing this perfectly with precision, precise values when we give it to the doctors or the orthosurgeons or the people. It's going to be very easy for them to go ahead with the implants. And of course, nowadays 3D printing is also accompanying this. The moment we do the measurements, we go with the 3D printing, they come out with a model, and then only they go for developing the implants. So these are certain very good applications where we find the impact of machine learning. And as I was mentioning, it's very, very useful in straightforward diagnosis of the problem. And next important thing, if I consider the patients as a stakeholder, if I consider like what is the benefit for patients over here when I try to apply medical image analysis? One, very accurate diagnosis in a very, very short time period, and with fewer trouble, like a stress level is going to be really less. They need not undergo lot many tests and everything. And finally, as I was mentioning, the tracer of the drugs, the next slide also I'll be explaining about it. The intake of that is really less because that also has some side effects for the patient. So that is also reducing over here. So these are all the needs why experts and physicians prefer medical image analysis. Yes, so I will just touch upon a few areas where medical image analysis has really brought out a tremendous change. One is a CT scanning. So nowadays, people take, very less time. Experts take very less time to analyze the CT scans. If you see the CT scan, PET scan, MRI and all, immediately we get the report generated. When the report comes out itself, we see the report mentioning this is the problem. It's not like that image has to be once again, of course, I do agree. Medical experts, they go through it, they try to be more confident. Whatever prediction has been made by the system is really perfect to a great extent. Of course, though it is not, we cannot develop an ideal system, next to impossible for anyone, but that 99% accuracy also supports for the physicians and expert to start the treatment as quickly as possible, so that literally we save the life of people. That is a specialty over here. And of course, nowadays we have algorithms which can deal with 3D images also. Same in breast cancer detection also, we have several algorithms, our deep neural network and convolutional neural network, they all work very well with 3D imaging. So through 3D images, if suppose I take for mammographic images only, when it comes to 3D images, we will tell it like slices. You will have multiple slices of the image. So it is not possible, practically for a radiologist to go through like, it will be like almost like 280 or 300 plus slices. So each and every slice, each and every portion of the image, if they have to, go through it, identify exactly where the tumor is, then identify whether it is benign or malignant is practically a bit difficult. But our model, our machine learning model can do it very quickly and precisely. It tells this is where the tumor is located and this is more towards a malignant end. That is the specialty of our machine learning algorithm. Similarly, our MRI, when it comes to the brain related problems, like how well they identify the tumors and all, even related to the cardiac arrest, so many things comes with respect to medical image analysis. They have done lot many examinations. Second thing is a PET scan. I wish to highlight one more point over here. As I was mentioning about the tracer, the chemical radioactive drug. So PET scan stands for a positron emission test. What it does is they basically inject tracer, a basic chemical inside the body of the patient, so that it goes and literally locates where the tumor is present in the body. So whichever location the tumor is internally, they can easily find out this is a place where the tumor is. But unfortunately, what happens, a dosage of this tracer injected into the patient body, at times it goes so high that is more, troublesome, or it is like going to create not much side effect for the patient. They take almost 1 or 2 weeks time to come out of this testing process only. So through our machine learning algorithm, that quantity of tracer which is injected to the patient's body has been minimized, and it's very easy to predict the lesions or the tumors present. Again, in a very minute stage, when it is too small, it is easy to treat it. So at a very minor stage itself, they're able to identify the problem. So these are all few major areas where we can see the impact of machine learning. Okay, so having said this, I wish to highlight upon what are the various steps. Now, practically, when we get into problem solving using machine learning, what are the various steps, the basic steps involved with respect to machine learning? So first and foremost, I wish to highlight about the data. All the speakers beautifully, they spoke about the data. That's really the key point. If not for the data, the concept of machine learning, artificial intelligence, big data, nothing exists. So data is a key, and equally collecting data is the biggest of all challenges. It's not easy to get the data. And even if we get the data, there will be like lot many things which is mismatching. So what is meant by data now? Just a small example let me give. So with respect to the patient information, let me take the same medical image only as a case study. So suppose a patient goes, they want to get detected for the cancer. So initially, if we see in the hospital, they will be entering all the patient information. That itself is a data. Patient name, the age, address, XYZ, everything is a data. Next, what type of scan they undergo. So through the scan, what all data, what all measurements, what all information the scan report gives, that is also the data. So everything put together becomes a patient data. Now, for example, let me get back to this X-ray. So here, if you see, you can see some labeling on this end. There are some words written over there, right? The image. So it is not just the own image, but we have some script, some text, so many information, the right portion, the left portion, not many information. Now this data, all this is data. All this is put together as a data when we try to store, basically. So what is next important step is, when I have so much data in hand, all the data is not needed for me in order to identify what is the problem in that image. So for example, the patient name is not at all needed for me. In fact, that shouldn't be revealed. And second thing, when I take this X-ray image, this particular text is in no way related to identifying the fracture in the bone. So these are all called as the artifacts. So something what is not needed for me in order to do a particular processing is called as a noise in that particular image. So noise is not a disturbance. Of course, it is a disturbance, but with respect to that particular problem, in this X-ray image, I want to identify something related to the fracture. So this data, as of now, is a noise for me. But suppose my image processing technique was to work on this particular text, then this whole bone image will become a noise for me. So whatever data I don't need now currently for my processing becomes a noise. So which out of so much data what I've collected, which I need to take up, what is needed for my current processing, deciding that, okay, and getting a better data. Out of some data will be missing, some data will be redundant. All this I need to handle. So in order to do that only, I go to the next step called as pre-processing. So first one is collection of data, next one is pre-processing, and the third important thing is transformation. To put in very simple terms, when I collect the data, it will be a combination of the data type. Let me take a very basic thing, what all of us know, so that it will be easy to understand. Some data will be like a text, some data will be numerical form, some data will be totally as an image, anything. So now I have to transform all the data in such a way, it will be easy for me to apply my algorithm. I cannot give multiple data types to a single algorithm. So that being the case, and at times I have to crop an image, literally come down to the point where the fracture is present. So many things are there. When I apply those operations, it is called as transformation. Thereafter comes my actual machine learning. So after applying all this, that data, I'm going to feed it. I'm going to process it using an algorithm. I'm going to train my machine. Tell if these are the features, if these are the characteristics present, immediately call that as a fracture. If these are the features that are present, like similar to an apple, red in color, this is a shape like that. So if these characteristics are present, call that particular thing as a cancer. In that, if these characteristics are present, call that cancer as a benign one, goes on. So later, after developing the model, I need to interpret, like I have to use some metrics in order to gauge, identify whether it is predicting properly or not. Because when it comes to medical application, we are dealing with people's life. So we cannot take risk. We need to literally talk with experts. A manual checkup has to be done in order to evaluate whether the algorithm is performing perfectly or not. So interpretation and evaluation has to be done. Then finally we get our model, which is a basic store of knowledge, which can do the prediction on its own. So this is the basic steps, the basic flow in any machine learning model. So yes, so whatever I've told now, just slightly I will try to go ahead. So in pre-processing, I've informed completely what all is happening. So one extra thing is the data cleaning and cleansing. What all unwanted data I feel, I try to remove it. As I told, I try to integrate all the data together. If needed, I crop the image. I try to resize the image, all that I do. And if needed, I also try to reduce the data. If I feel so much data is present, redundant data and all, I try to reduce it. So all these operations put together will be called as pre-processing. So for each and every step, we have different techniques and algorithm, right? And of course, I'm not touching upon the techniques in depth in this session. Fine. So I'm just giving you a gist of it. So pre-processing techniques are like, if I take an image, each and every particular data in the image, okay, will be obtained through the pixel. It's called the picture element. That is nothing but a pixel. You can just correlate an image to a graph sheet. So each and every cell in the graph sheet is nothing but a pixel in an image. So that particular picture element, the intensity, the combination of RGB value, red, green, and blue value in a color image, or the combination of the black and white, those values will be giving me the actual data from the image. So through that, I try to identify what is the brightness, whether the image is really clear. Next one is, if it is not clear, I try to make it more clear, more better. That is nothing but gray level transformation. And histogram also deals in the same way. It will help me to improve the contrast of the image. Next comes a geometry transformation, wherein I try to rotate the image or try to resize it. So all these pre-processing techniques will be helping me in getting the actual image that is needed for processing. Yes. So basically this we have seen. So what machine learning algorithm does is, it is going to make a machine to learn from the past data. So our machine will be able to learn things and predict something. So this all of us know. The normal programming, if you see, we have data and the algorithm, we apply the algorithm, get the result. But in machine learning, we know if these are the characteristics, it has to be called as apple. So what is the algorithm I can develop so that when I feed in this data, my machine calls this as an apple. So this algorithm developing only is a major challenge when it comes to machine learning. So how well we develop the algorithm, or how well we choose an algorithm in order to train our machine. Yes. And this is something very important I thought of sharing. In any particular machine learning project, need not be only medical image analysis, basic. Any machine learning project when you take, this would be the basic step. So first and foremost, if you see, it is, this is something called as a features or the attribute. As I told, the characteristics that we try to collect. So using these characteristics only, we try to tell this is a dog, this is a cat. Every object has certain characteristics through which we try to name it. So those characteristics, first and foremost, I try to store it in a table. This is basically my data. If not for this, I cannot proceed. Next one is, as I told, we need to choose a perfect algorithm which will be having the capability to learn from this data. And very important thing is, when I have this collection of data, the characteristic, I try to divide the data into training and testing set. Training set means using that particular collection of data, I keep on informing my model, my machine. If these are the characteristics, call it as a dog. If these are the characteristics, call it as a cat. If these are the characteristics, call it as an automobile. So this is training. So after having trained the machine, how will I get to know if my model is really performing well? So among this data, I try to have certain rows reserved. So that will become my testing data. So now when I feed in this particular data to my model should be able to tell very perfectly whether it is an animal or it is an automobile or it is an object anywhere around. So based on the prediction results, I will be able to evaluate the level of my algorithm and the performance. Then I will get the confidence in order to feed in the new data. The same thing happens in medical imaging also. So we have so much patients data collected from real-time hospital and from existing databases. We collect all these features, select an appropriate algorithm. Of course, we apply all the steps, select an appropriate algorithm, train our machine. Once I feed in this feature, identify the disease. So it should be able to identify. Only when the accuracy is suitable for the experts, only when the experts evaluate the accuracy, we go in for feeding a new patient's detail. This is how basically any machine learning project will work. Right. So with respect to medical image analysis also, we have the same types of machine learning. Basic three things are supervised, unsupervised, and reinforcement learning. I make it very simple. It was already handled by Ms. Rajani also. So supervised learning is, I inform my model, if these are the characteristics, it should be called like this. If it is red in color, it is edible, right? If this particular shape, it has seeds and everything, call it as an apple. So both the data as well as the result, I feed into my model. And I choose an appropriate algorithm which can easily make my model to do the prediction. That is supervised. It is totally trained. My model knows this should be the result for this. See, if these are the characteristics, call it as a square. If these are the characteristics, call it as a triangle. So the label, the final result also I feed into my model. Unsupervised, I leave it to the self-learning of the model. I just feed in all the characteristics. So the model will be checking each and every data. In multiple data, it will be saying, okay, these are all the characteristics which is continuously repeating. So I can group it together into one thing. It all belongs to one category. It doesn't know to name it as square or triangle or apple, but it knows very well all this belongs to one type. Push it into one type. That is what Ms. Rajani mentioned as your clustering. So wherein it will be grouping. So it knows very well all dogs have the same characteristic that your machine will be able to identify. That is unsupervised learning. So beautifully, it will group the data and it will be able to do some unknown prediction, which as human, we don't know. That is a speciality of unsupervised learning. So the machine will be coming out with some common characteristics, which we might miss through a human eye or through our prior knowledge. That is a speciality of unsupervised learning. Reinforcement learning is almost like, pampering a child or like motivating a child to analyze and identify whether something is correct or wrong. So when a child does something correct, we immediately motivate. We tell we praise a child, we give some particular reward and tell what you have done is correct. So the child continues to do it. When something goes wrong, it faces some problem, it will learn and again, it will try to avoid it. That concept comes under reinforcement learning. So when it comes to medical image analysis, most of the time we go for supervised learning, taking patient's life into consideration. And of course, we do apply unsupervised learning when we want to predict something new, something which is not known priorly, totally new. For example, our new virus, the virus attacks, what are happening, all that requires unsupervised learning. Yes. And yeah, so I've just highlighted the same over here, like how it is applicable and everything. And yeah, this is one more thing, that is dimensionality reduction. Why do we go for dimensionality reduction? In the sense, this is another important step with respect to medical image analysis, as well all machine learning project. So as I was mentioning those characteristics in the table, I mentioned a lot many characteristics will be there. Those are called as a features. So when I have so much of feature in hand, it's very important for me to have an idea about how much feature is actually needed. I have to go for reducing it. I have to select the important features, extract that, and then go for training my model. So for that, the concept what we use is dimensionality reduction. We try to identify which is redundant data. We try to avoid it, fill the data needed, and then choose the appropriate features. So this is another important thing which will be used in medical image analysis. And yes, so when it comes to the feature selection, the next important critical concept with respect to your medical imaging, because we can't take a risk. We can't miss out any important feature. So we should be very careful. So which approach we use? For example, wrapper approach means I will be using some specific algorithm. For that itself, I use some techniques in order to choose the appropriate feature. In filter approach, when it comes, I do it randomly. Like I have all the feature with my prior knowledge. I go for selecting which characteristics are important. Hybrid will be combination of all. So like this, for each and every step in the whole machine learning process, we have several techniques and algorithms. Yes. So obviously the last step is nothing but the classification. So when it comes to classification, the very important step, wherein my model, my machine should be able to tell very perfectly whether that particular problem diagnosed in the patient belongs to this disease or to some other disease, whether it is this particular cancer or not. If it is cancer, as I told, which particular stage it is, whether it is too risky, is it life-threatening, goes on. So that is nothing but my classification. In fact, in the previous slides when I showed, classifying an object as belonging to square, set of rectangle. So the final result of any machine learning process or the algorithm would be the classification. So how well the model classifies and matches the input data to the result is the actual challenge. That gives the efficiency. That proves the efficiency of the machine learning model and the algorithm. So this is the final part in any ML program. So with respect to classification, I just wish to touch upon the neural network. So one of the technique which is highly used in order to, perform the classification is neural network. So it almost, it's a model which, imitates a human brain. So however neurons work, the same way, the mathematical computations are going to be placed in the intermediary neuron. It has several layers. The input features are going to be fed in. We have several layers of neuron. Each neuron will be having certain computational operation, activation functions, which will be working upon the input data. And through the computational function, it will be easy for us to do the classification, to classify whether the data belongs to which particular class. So this is the main concept behind the neural network. Fine. So with respect to the application, the breast cancer detection also, in order to identify the stages, for example, I had used so many features and several layers. This almost, depicts the convolutional neural network. So wherein all the features, it is going to be fed into a different computational concept, which will be, working upon those input features in a particular manner, and easily we can try to predict which particular stage that tumor belongs to, very early stage or advanced stage. So it's like through the image itself, we are going to mark upon the location where the tumor is present and immediately give a report telling it is a malignant tumor of this particular stage. Yes. So as I told, in order to evaluate the performance of the model, we have several metrics used. These alone are not the metrics. These are few of the very basic and commonly used metrics. Apart from this also, we have several metrics. So when it comes to the medical application, accuracy plays a very important role. Our model has to be as accurate as possible. It should have very less error. So efficiency is very important. And we have to get the response as quickly as possible. If suppose a model is going to take 2 weeks time, which is really high than the lab test result, nobody is going to prefer an ML model. So response time, all these metrics has to be taken, and we should have some benchmark also in order to compare the performance. So this is about evaluation and interpretation. Yes. So I had tried to give an overview about the medical image analysis, how well we can make use of machine learning to do the prediction, and how a model is being built, the various steps involved. I have given the overall gist and an outline. I have not gone too much in depth. I know very well it will be too heavy and too much high level. So my intention was to make you understand about how a machine learning model can support medical image analysis. Hope all of you have got some understanding about it. Thank you. So any questions, feel free to share over chat, or you can feel open to share it directly. Thank you.
Thank you very much, madam. Very nice presentation. Really, it's wonderful. It's a totally different line of that is image processing in the medical field. That is very critical. More accuracy is required. So really people have done an excellent PhD, also doctorate in a particular area where a lot of projects is going. And the implants, what is shown, and that is all, a lot of things are available. Actually, even recently, my father got a surgery in an implant and hip injury. There, the analysis is not properly done. That is what we have missed my father, because the analysis part, they are not able to predict whether it is the implant is gone inside or it is properly suited. So finally, we gone to other hospital and find totally fine. The last stage I lost my father. So this is what happened. So really is the critical part actually. So the medical, particularly the medical field, the image process is most important. So whatever the model you shown, it's a very good model for the people to think on it. So they can do a lot of research in this area. It's a very nice presentation, madam. Thank you very much.
Thank you.
Thank you. Thanks a lot. So, sir, Dr. Umachandran,
Yeah. Any questions if they have?
Yeah.
We'll have and
any questions? You can even put it in chat box also.
Yeah. Okay, I've seen some questions like, they were
Yes.
asking about food industry and all.
Yeah.
See, and construction industry. Friends, let me be clear. Machine learning or deep learning depends on sensor. See, sensor is one which is going to sense an activity. Okay. See, if you have a sensor, what you have to do is whether the sensor can recognize what you want. If that can be done, then your application is perfect. If it should recognize. Then second, once it recognizes, what it has to do is it has to probabilistically analyze. See, for example, you see a face. The face can change in various positions, various things. So every probability has to be taken. So that is when a sensor is working, it should probabilistically analyze. That is the second requirement of a sensor. The third part is it has to translate into your requirement. So if you can recognize, then you sense it, then probabilistically analyze, and then translate, then you can apply it anywhere. It all depends on what sensor you are going to select. That is the more important thing. That is what Professor Gopinath also said. Sensor is the one which goes to play whether it is going to be a success of a ML or a DL. So you should be very careful in doing that. Once you know it, then you can do it. Then comes the other part, classifier, or you have a kind of a predictor. Whether you have it in a supervised model or an unsupervised model or a reinforced model, whatever. See, this is a big application process. Okay, so this inputs, whatever our experts have given, please take it with you. When you apply it in a project, then you will understand where exactly each one of it stands. Okay, so with this, I wish to give it to Professor Gopinath to wrap it up.
Thank you, Dr. Umachandran. Today we had a very nice presentation from various experts. We started nicely with the Professor Ravinder Rena with the introduction of this machine learning and deep learning, and nicely given by Dr. Umachandran, Industry 4.0. The entire architecture was given by him, and how to use it and how the industry is using machine learning and deep learning. A nice presentation. And next, the Rajani madam, Dr. Rajani Thakur, as technical consultant, has given a very good introduction of machine learning, how to differentiate machine learning with artificial intelligence, and our various models available, how to choose a model, how to choose an algorithm. All those things clearly explained by Rajani Thakur madam, and a very nice presentation. And Joshua is a very good case study, as put it, because so many case studies today, the social media, a lot of the fake news are coming. So identifying the fake news is very typical task today. So nicely is given a very good case study like that. The students also take different case study to analyze it. So that is a very nice presentation. Next, finally, the medical image, the critical analysis part is Dr. Varalatchoumy madam, and has given a very nice topic. Is really is eye-opening to all of you who are the beginners, or maybe the middle level or higher level of machine learning, deep learning. All these experts talk Really, you would have got a lot of information. It's eye-opening to you. So from that, you can start doing research on this. And I want to add up one more thing. This Google search, the Google search, what you're doing regularly is one of the machine learning concept. Say when the Google search was built in, okay, initially they would have started with, say, assume that machine learning and deep learning, if you put it, you would get only deep learning, machine learning, whatever you typed in. The people would start working on it. They would have searched for application, machine learning application. So that was captured by the machine. During the machine was trained, the various input given by the customer throughout the world. Now today, if you type it machine learning, you get n number of the outcomes are coming in. You can search even whatever you think that is available in the Google search. So this is what a simple Google search is a machine learning and deep learning. That not deep learning, you can say it's a machine learning. The deep learning is the next level. If you have n number of learnings, if you add up, that become a deep learning. That is what I think. And even Flipkart, Amazon, things are doing it. And autonomous vehicle, I went up with this small introduction, the autonomous vehicle. How the autonomous vehicle things are happening. So you have to train the vehicle. See, you have to sit physically, because we have done a project in my college. What is that? Is that you have to physically sit in the car and you have to drive a car in a particular area where your ups and downs or barriers and dividers are there. You have to run a car, okay, so that the machine, the automobile will learn how the road condition is available. Because autonomous vehicle, very, very difficult task in India, because we have so many hurdles are there. So that we are trained actually from Sriperumbudur to the Punamalli, we trained the autonomous vehicle. We sit literally and we trained it so many times. Now we can able to run a vehicle without a human being, autonomous vehicle. So that is called training. You are training, keep on training the hurdles available in the road so that the machine will get trained, and based on that, it automatically will run. So this is what a simple example for autonomous vehicle. Like that, whatever the models given, whatever the algorithms given, okay, whatever the industry 4.0 cover, all those things, all are interconnected. Today, we are totally, even though it's a very different domain, everything's connected for particular application. So I request all of you, the students who are here, okay, you need to start working on an application. First, you have to find out application. Then you have to go for mechatronics system. We have to design a mechatronics. What are the components are required for doing a particular system? Then go with all the machine learning, deep learning, and all those things slowly, and finally you complete the project. This is what even we are practicing in our college. Okay, we are practicing. So with this, I will complete my valedictory speech, and thanks one and all, and thank all experts for the valuable speech, and I thank Dr. Umachandran for this coordination. It's a very nice presentation. Thank you very much.
Yeah, thank you all. Now we expect people like you to also participate in the conference being carried out in October by JFP publishers. Wish to have you all in other series of webinars also. Thank you all for your participation. Participants would be getting their participation certificates. Thank you all. Bye.
Thank you. Thank you very much.